It's the early 1940s. The world is at war, and victory depends on supplies crossing the Atlantic. Food, fuel, weapons, all threatened by enemy submarines. The US needed a fleet fast. The answer, the Liberty ship. These cargo haulers weren't pretty, but they were built for speed. Prefabricated, welded, and assembled in days. The first, SS Patrick Henry, launched in 1941. Soon, a new Liberty ship hit the water nearly every day. Thousands formed a lifeline, braving icy waters and enemy attacks. For builders and sailors, these ships were more than steel. They were hope. But beneath their sturdy exteriors, a hidden flaw lurked. The steel hulls held a secret vulnerability, invisible to the naked eye. Under the right conditions, cold, stress, this flaw would reveal itself. The consequences? Sudden, catastrophic, and baffling to engineers. The Liberty ships were a triumph of mass production, but the universe had other plans. Materials we thought we understood could behave in ways we never expected. The stage was set for a mystery that would challenge the very foundations of engineering. What was this flaw, and how could it threaten the Allied war effort? The answer would come, but only after disaster struck. The story of the Liberty ships was about to take a dramatic turn. The first shock came in 1943. The SS Schenectady, docked in calm waters, suddenly split in two. No storm, no attack, just a thunderous crack. Brand new, never in combat, the ship was lost. And it wasn't alone. Across the Atlantic, Liberty ships were cracking apart, some vanishing, others found with gaping hulls. Survivors described a gunshot bang, then the groan of tearing metal. The ships meant to save lives were becoming death traps. The crisis was urgent, engineers were stumped. On paper, these ships should have been strong. The steel was standard, the welding modern. Yet nearly 1,500 of 2,700 Liberty ships suffered major fractures. President Roosevelt ordered an investigation. This was no longer just engineering. It was a scientific mystery. Teams gathered steel fragments, examined them under microscopes, and analyzed their chemistry. They searched for a hidden weakness. Something that could turn tough steel brittle as glass. The clues lay in shattered hulls and the cold Atlantic depths. The answer would change engineering forever. What was causing these catastrophic failures? The investigation would reveal a secret at the heart of the material itself. The fate of the war and the future of engineering hung in the balance. The Liberty ship's flaw was about to be exposed, and the lesson would echo far beyond the war. Scientists discovered the steel's hidden personality, strong and flexible at room temperature, but dangerously brittle in the cold. In icy Atlantic waters, the steel lost its toughness. Small flaws, tiny cracks from welding or sharp corners, became deadly. This led to a breakthrough, the ductile to brittle transition temperature. Above it, steel bends, below it, it snaps. In the cold, a tiny crack could race through the hull at nearly the speed of sound, splitting the ship in seconds. Welding, once seen as a strength, created continuous seams, perfect highways for cracks. Unlike riveted ships, where cracks stopped at plate edges, welded Liberty ships could unzip from end to end. The mystery was solved, a mix of steel chemistry, freezing temperatures, and design flaws. The ships weren't weak, they just weren't tough enough for the cold. This changed how engineers thought about materials. Strength isn't enough, toughness matters. The Liberty ship's failures became a lesson in the hidden rules of matter. From disaster, a new science was born. The world would never build the same way again. The lesson was clear, revealed by shattered steel. The Liberty ship disaster sparked a revolution in engineering. Shipbuilders changed steel formulas, added manganese, and redesigned hulls with rounded corners and crack arresters. These fixes launched the science of fracture mechanics, predicting how and when materials break. Today, every bridge, plane, and skyscraper uses lessons learned from those failures. Engineers now test for toughness, not just strength, building structures to survive flaws. The Liberty ships taught us that failure is a powerful teacher. From tragedy came wisdom that saves lives and shapes our world. The story reminds us, every structure is a conversation between human ambition and the laws of nature. We build smarter, safer, and more resilient, thanks to the lessons of the past. The legacy of the Liberty ships endures, forging a safer future for all.